Hello guys, this video is for pre-cal week 6, Thursday. Our topic for this lesson is actually it is Thursday and Friday. And our lesson is on polar coordinates. Okay, so I have pre-written some notes so I can save some time. We're gonna start out with polar coordinates. Actually, as we said, it's a coordinate point. We have a parentheses and a comma, but this is no longer x and y. Okay, for when we talk about polar, we are actually talking about a letter called r, and we have a theta. Okay, and this polar coordinate of a point in a coordinate plane, the first letter, the first coordinate is r. Put it right here. Is the distance from the origin to the point. Okay, I'll show you in a picture later what that means. And then the second part, polar coordinates, is theta. So the theta part, it's actually the angle. Remember, anytime we talk about theta, that is referred to the angle. And this is the angle between the positive horizontal axis and the line segment. Okay, remember when we talk about positive horizontal axis, really there's only two axes, right? There's a y-axis and then there's the x-axis. So if we're talking about horizontal, we're talking about x, and positive, we're mainly talking about this side right here. Okay, and then they said from this line to the line segment, it represents the angle. So let's pretend if I go up here, let me make that a more straight line. So let's pretend we have a line and it's going up there. This line itself, its distance r, okay, and then theta, it's right here. Okay, so if I have to sketch, let's set up an example. If I have to sketch the line segment from the origin to the polar coordinates. Okay, if I say 3 comma pi over 4 or 1 comma negative pi over 3, two different questions. Okay, then you would want to start off by setting up your grid. Okay, and then we first look at the angle. The angle is asking us pi over 4. Okay, I will start attaching this. I'll attach this to our assignment for this week, so you guys can kind of refresh your memory on all of the angles. Or if you have your own copy, that would be perfect. But pi over 4 is really 45-degree angles, right? So I would have to go up this much, and that's my line, so I'm going to write the 3 here. This angle itself is your theta, pi over 4. Okay, and that's how you sketch a polar coordinate. And then number 2, if I'm looking at 1 comma negative pi over 3, we are looking from this line down. Okay, pi over 3 is around like a little bit more than pi over 4, and we draw our line. And that's 1. This would be negative pi over 3. Okay, that's how we sketch. Now the next part, we're going to be converting from polar coordinates to regular coordinates. Okay, so that means we're converting from r comma theta, sorry, did I say regular? Rectangular. Rectangular is the ones that we usually work with, x comma y. Okay. Let me do a little explanation using letters first. let's pretend we have a triangle, a right triangle right here. Okay, a right triangle, and we have our theta in here. Okay, what's the bottom length represent? Usually, if we go to left and right, that's our x coordinates, right? And then if we go up, that's our y coordinates. And just up here, we said that that diagonal length is our r. Okay, so basically all those polar coordinates and rectangular coordinates, they're all in this picture. But how do we connect them together? Okay, this is when we have to use our cosine and sine. So if I'm using my cosine, okay, of my theta, how do I write my cosine theta? Remember, cosine is adjacent over hypotenuse, which is x over r. So that means sine theta would equal to y over r. And then since we are going from polar to rectangular, we are solving for an x and we are solving for the y. So I'm going to multiply r to both sides and multiply r to both sides for this one as well. So in this case, r is going to be represented, x is going to be represented by r times cosine theta, and y would be represented with r times sine theta. Okay, so r cosine theta, comma, r sine theta is our big formula. Okay, I'm gonna do a big box around this. Okay, and that's it so far. So I'm gonna give an example to this part, to this conversion, and then I'll do vice versa. Okay, so let's do example. Find the rectangular coordinate with polar coordinates 5 comma pi over 3. Okay, so what do each of these represent? This is our r and this is the theta. So follow the formula from earlier and to solve your rectangular. And because we are dealing with pi's and things like that, we're gonna try not to use our calculator. The most that you can use is this chart right here. Okay, and I promise you it's really easy to use. So let's start out with 5 and then cosine our theta, which is pi over 3. And then we have our 5 sine pi over 3. Okay, if you remember, our formula earlier was r times cosine theta and r sine theta. That's how I got my number substituted. So let's keep going. I know 5, I'm going to be multiplying to cosine pi over 3. So let's go to this chart. Where's pi over 3? It's right here, right? So look at the coordinates. It's 1/2 and square root of 3 over 2. So I'm going to go back to my notes. Instead of writing cosine pi over 3, I'm going to write 1/2. Instead of writing sine pi over 3, I'm going to write square root of 3 over 2. And we have our 5s. Okay, almost done. So left side, we're going to multiply it together, which is 5 over 2. And the right side is 5 square root of 3 over 2. That's your answer. Okay, that's the way if you're looking at the unit circle chart. Okay, for some of you guys, you don't want to look at the unit circle chart. You actually want to memorize or want to actually do this by drawing it out. You can actually sketch out a rectangle And if this is pi over 3 right here. Remember, another way to say pi over 3 is if you take 180 divide by 3, that's another way of saying 60 degree. Okay, what's always diagonal from 60 degree? That's your square root of 3 over 2, right? And then at the bottom, it's always the 1/2. So that's why the 1/2, we used it, the horizontal part, we use it right there. And this one, we use it right there. Okay? And then the work is the same from there. So that's the only example for that one. I will show a little bit more later from your homework question. Let's do another conversion. Let's try to convert from rectangular coordinates to polar coordinates. So rectangular coordinates, that's the x comma y, and polar is r comma theta. How do we go from x comma y to r comma theta? Okay, we have to go back to the picture that I drew earlier, which is the theta here, x at the bottom, y on the side, and r on the hypotenuse. Okay, is there any way that if I'm given my x and y, I can figure out my r from here? Using triangle, right triangle. Okay, some of you probably have thought of Pythagorean theorem. Pythagorean theorem is when you square your legs, add them up together, and it will equal to your hypotenuse square, which is x squared plus y squared equals to r squared. Okay, again, we're solving for r, so we're going to do a square root on both sides. So r would equal to square root of x squared plus y squared. That's how we're going to find our r. But we still need to find our theta. How do I find our theta if only these two information are given and we got to find our theta? Finding the angle, remember we always have to use trig ratio, which is tangent theta equals to y over x. And then to have theta stand by itself, we got to do the inverse of tangent. So we get canceled out. And then theta now would equal to inverse tangent of y over x. Okay, so now let's use what we just learned and do a few examples right here. Actually, I'm gonna box this too. Okay, so example, given rectangular is 1, 1. Find polar coordinates. Okay, so we have to find our r, and then we have to find our theta later. This is our x and y. Okay, you can pause the video if you think you got the hang of it. Try to do it on your own, and then check my answers in a bit. I'm gonna substitute 1 to the x and 1 to the y, and we're gonna put a square root to it. This equals to r. Okay, I'm following this step right there. And we're gonna keep writing. 1 square plus 1 square is 2. Square root of 2. That's our r. Okay, so we got our r, and now we're gonna get our theta. Okay, so 1, 2. From our picture, or from our right triangle, actually, let me do it like this. If I have to graph this point, 1 is here, 1 is here, right? So this is my point. And I'm gonna draw my triangle. So these are 1s. That means what would be your theta? And it has to be one of these in this picture. Okay, if they are exactly the same, that means it would be your 45 degree, which is pi over 4, because the left side is the same as the right side. Okay, so our theta is pi over 4. Okay, so to finalize our answer, it will be square root of 2, comma, pi over 4. That's your answer. Okay, if you're going to use this tangent, inverse of tangent of 1 over 1. If you put it in your calculator, if you put it in radian form, the number, you may not recognize it. But if you put it in degree form, okay, in degree, this would be 45 degrees. So you kind of have to convert it back into radian, that you know this is the same thing as pi over 4. Okay, I'm gonna show you 2 questions that you can practice. So rectangular to polar, which is 1 comma negative 1. And then if you can also do polar to rectangular, I'm going to give you 5 comma and pi over 2. Yeah, let's do that one. Okay, so the first one, 1 comma negative 1, because when we put it in r equals to square root, it would be 1 square plus negative 1 square, which still gives you 2. Okay, so that part doesn't change. But for our picture, 1 comma negative 1, 1 is here, negative 1 is down here. So this is technically where the point is at. So when we draw our picture, it will look like this. Okay, since these were my 1 and negative 1, the angle went down this way. Okay, so we are actually looking at pi over 4, but the negative version of it. Okay, so we have square root of 2, comma, negative pi over 4. That's your answer. The other one, 5 comma pi over 2, we got 5 cosine pi over 2 and 5 sine pi over 2. Okay, pi over 2 is your 90 degree, which is at the top, which is like up here. Okay, what's the coordinate for that part right there? It is 0, comma 1, right? So I put 0 and 1, and I drop down my 5. Almost done. We got 0, comma 5. That's your answer. Okay, I'm gonna show you 4 of your homework questions. Let me see. On Thursday, you're doing from 2 to 12 even, so I'll do 2 questions from there. From Friday, you're doing 14 to 28, and actually I will do 3 from there. Okay, so let's look at number 4. Actually, let me tell you real quick what the question is. Real quick. So 2 to 12, you are converting from polar to rectangular. Okay, you're given all polar points, so you're turning them into x comma y. And then for Friday's homework, you are going from rectangular to polar. Okay. So for number 4, your polar coordinates is 5 comma negative. Oh, did I just do that one? Let me see. Oh no, I did pi over 2. So if this one is negative pi over 2, we are still going to write our 5 cosine negative pi over 2. And the other one is 5 sine negative pi over 2. So remember, negative pi over 2 in our coordinates, it's down here, because this side is the positive pi over 2. So the negative is down at the bottom, which is 0, comma, -1. Okay, so I'm going to put 0 and -1 in parentheses and just drop down the 5's. So my answer would be 0, comma, -5. That's your answer. Next one I'm going to go over is number 12. So number 12, we have 13, comma, 8 pi over 3. This is polar. So to get our rectangular, we got to figure out was 13 cosine 8 pi over 3 and 13 sine 8 pi over 3. 8 pi over 3, is that even in this picture? Okay, look out for those pi over 3. So we have pi over 3, 2 pi over 3, and then this is 3 pi over 3 because it's pi. And then we got 4 pi over 3, 5 pi over 3, and then 6 pi over 3 is right here. 6 pi over 3. And the next one is 7 pi over 3 is going to come back to the same as this part, this length right here. Okay, it just repeats again. So if this is my 7 pi over 3, my 8 pi over 3 would be over here. Okay, and then the coordinates what we're using is this one right here, -1/2 and square root of 3 over 2. Okay, and we're going to do all of this. So -1/2 and square root of 3 over 2. Again, it makes more sense if you have it like side by side. So I'm going to take these numbers and drop the 13. And this is going to end up being -13 over 2, comma, 13 square root of 3 over 2. That's your final answer. Don't forget those negatives. Okay, I'm going to go on and do number 14. 14, now we're going from rectangular, which is square root of negative, oops, what am I doing? Hold up, square root of negative square root of 3, comma, 0. And we're changing it to polar. Okay, so if this is my x and y, remember whenever we're giving our x and y, we're going to use our Pythagorean theorem. So it'll be negative square root of 3 square plus 0 square, and we have our big square roots around it. This square root and this square get canceled out, and the negative also get canceled out because we're squaring it. So we're down with 3. This totally go away. So square root of 3 is what's left. Okay, so we're actually done with the first part. Now we got to figure out our right side. So in our picture, negative square root of 3, it's over here. We don't go up and down because it's 0. So what direction is this side in our chart? It's pi, right? So that's our answer. Okay, let's do number 18. Number 18 is 4, comma, -4. And do your square roots. We got 4 square plus -4 square. This is going to be 16 plus 16, which is square root of 32. Okay, square root of 32, we can simplify this. We can break it into 8 and 4, 2 and 4, and we have a pair of 4. I'm going to keep the 4 outside, and the 2 is its leftover, so it's 2 stays inside. Okay, so we got our R ready to go. And now for our other part, let's look at our picture. plot this point. Plot 4 comma negative 4. 4 is here. Negative 4, it's down here. So there goes our picture. Okay, if your left and right are the same number, then even though their signs are different, then what would be this angle? We actually went down pi over 4, but negative. Okay, some of you guys may say that, oh, it looks like it's 7 pi over 4 right here. Honestly, 7 pi over 4 is not wrong. It's actually not wrong. You can either use that or you can use negative pi over 4. Okay, so I'm going to write my answer. 4 square root of 2, negative pi over 4, or if you say 4 square root of 2, what was it? 7 pi. 7 pi over 4. That's also correct. Okay. Last question. I'm going to do number 24 because that one actually, that side of the homework requires calculator. This part requires calculator, so make sure you have your calculator ready. This question is 6 comma negative 5. So let's look at our square root. 6 square is 36. Negative 5 square is 25. So we have square root of 61. Okay, you can totally keep that square root of 61 on the side, but you just have to use your calculator for the angle. Okay, because I know 6 and 5, I can't really find anything in this chart that can help me put everything in like pi. Okay, so I'm going to keep that 6 and negative 5 and put that in my inverse tangent. Remember, our formula was inverse tangent, negative 5 over 6, which is our y value over our x value. Okay, put that in your calculator in radian form, because all our answers happen in radian, and you should have gotten an estimate of negative 0.69. And that's your answer. Okay, so get your homework done, and if you have any questions, feel free to text me or anything. And if you would like me to have a Zoom session, any of these like school days, feel free to let me know. And if it's like working hour and you don't see me having a Zoom meeting, most of the time I can actually just host one. Okay? All right, guys, have a good day. Bye.